Okay, so we are now going to be given a graph and we have to come up with the function that applies. So what you really want to start with is who's the parent function? Yeah, in this case, it's a quadratic, right? That's a parabola. So my parent function would be y equals what?
Y equals x squared.
Yes, so there's my parent function. So I guess step one is determine your parent function. Okay, so usually you can do that just by looking at the shape of the graph. So in this case, we have y equals x squared. Okay, cool. It might be helpful for you to sketch the parent function on the same grid. You don't have to. But sometimes it can be helpful just to see what have I done to the parent to end up here. So I'm going to do that. I'd have points here, and then I'd go up 3. Okay, so here, actually, I'm going to do it in a different color. I'll do it in red. Again, you don't have to do this part, but I find it helpful sometimes. See exactly what did I do. Okay, so there's the parent. So one thing that you see right away is that I've done what? Well, yes, I did that. Oh, grew it. I think I said wrote it. What? What? Grew?
Drawn the parent function on the graph. That's what she's trying to
Oh,
say.
I drew the parent function.
Yeah,
I did.
not
Drew. D-R-E-W. I drew it.
So I
Yes.
didn't, I said drew.
But the parent function does, I do have some changes that have occurred, right? So, someone tell me one thing that you know that I've done.
Oh, up 3.
Yeah, because in my vertex, it's kind of easy to pick a point and follow that one point. The vertex has shifted up 3 for sure. So I know that one thing I'll be doing, so I'd say step 2, determine transformations. So in this case, one thing I've done is I've shifted it all up 3. Okay, but that's not it. I've got more. What else happened? It has been flipped over. I can combine these 2 in 1. Because if you notice, I didn't just flip it over. It's flipped over and kind of stretched, right? So
So -2.
So what did I actually do to my y values?
Sorry, I'm not allowed to say anymore.
Yes, I heard it, multiplied by -2. That's what I have done to my y values. How do you, so look, here's how, I know it's weird because they're upside down. Normally on the parent function, from the vertex to get to the next one, you go up 1 over 1, right? Now, if I look at the final graph from the vertex, I went down 2 over 1. So instead of going up 1 over 1, I went down 2 over 1. So to get down, I'm going to multiply by negative. And now it's at 2. That's how I know, okay, I'm going to multiply by -2. All right. Now your step 3 is to just write the function kind of all together. So we're really kind of just going backwards from where we were. So step 3, I want to compose my function. So I know I'm going to take y equals x squared, and I have to show these things happening in it. So I'm going to y equals x squared. This one's easy. How do you show up 3? I just add a +3 on the end, right? That's easy. So I took care of that part. How am I going to show? Oh, I forgot, multiply y's by -2, right? I didn't multiply the x, I multiplied the y. So how do I show that? Multiplying the y's by -2.
-2 outside parentheses x on.
Right. So if you, yeah, if you run to be really fancy, you could do it like that. So I'm gonna write it all nice and neatly, -2 x squared, and then the +3. I'm gonna add a step 4. Check a point or two. So if I'm using my function, let's see, let's just start with 0. If I plug in 0, I should get out 3. Okay, that one works. If I plug in 1, I should get out +1. Okay, good, that one works too. Oh yeah, sorry. Okay, so now listen, sometimes in here in step 2, maybe you're not 100% certain, so try what you think you're doing when you come up with your function. It really is so important to do this final step though, to check and make sure. Yep.
On my paper, I did a parentheses around the X, is that the same thing?
Same thing,
Okay.
as
Then
long
I
as,
did it right.
Yep.
First time, before you.
oh, good. Okay, try the second one. Figure out who is the parent function, what transformations are happening, write the function, and then check it with a point or two. Okay, who's got an answer? Cedric, go ahead. What do you think it is?
Y equals x minus 2 cubed plus 1.
Did you write it like this and like that?
Yeah.
Okay, let's see if we all agree. First of all, is it the x cubed? Is that the parent function?
Yes.
For sure. Okay, so the parent function, I'm just gonna sketch it real quick. You don't have to. But it starts here. We have 1, 1, -1, -1, and then it kind of goes off. So I have that. So now that I see both of them, I always kind of like to follow the center dot. And the center dot has certainly, doesn't look like I've changed the graph any. They're still going up 1 over 1, down 1, back 1. So there's no stretches or shrinks or things like that. I'm just shifting this one. And looks like we're going right 2, up 1. This is perfect. Make sure that when I'm shifting to the right or left, that that's going in there with the x. So when I say in there with the x, and the parent function is y equals x cubed, right? So you need to make sure that that shift of 2 is also being cubed. That's in there with the x. Okay, so I get it like this, and then I just shift the whole thing up 1, so that's a +1 on the outside. Plug in a point or 2. If you plug in 2, you should get out 1. I do. If you plug in 3, you should get out 2. I do. Oh my gosh. Isn't that nice? Okay, flip. Okay. Take a moment on this one. Determine that parent function, see what transformations are happening. Oh my gosh. I'm gonna draw the parent function myself. You guys just double check your equation, whatever you come up with. Plug in some points, make sure they're right.
-2.
Other people are trying to figure it out.
You just asked me.
Oh, it's your paper.
Okay, I heard an answer floating around out there. Katie, go ahead. Yeah, go ahead.
Wait, let me get my. I got -2 absolute value of x minus 2 plus 3. What?
I got some.
I got -1/2.
Oh,
Yeah.
well.
And said right
that's what I
here, a
meant,
negative
that's what I
one
meant,
half.
No. It's addition.
Did you plug in points, Katie?
Yeah, totally.
No, she didn't. I see no point.
He's trying to raise everybody.
I don't think,
But I got it right.
All right, let's go over all of these
Red and
pieces.
black.
Okay, and actually there is, so you guys are saying you got a negative one half here?
Yeah.
Does that look better? There is, there's another way that this could have come out. So if you have something a little bit different, you're not necessarily wrong yet. So let's follow through some of the pieces that we have. So from the parent, I am, well, first of all, obviously the parent is absolute value of x. Hopefully you got that. It certainly is upside down. So I need to multiply y's by -1. I have shifted to the right 2 up 3. Right 2 up 3. And then, but that's not all that has happened, because if you take a look, normally from the vertex, I go up 1 over 1, up 1 over 1. That's not happening here. It's going, so you know, if I was flipped around the other way, I'd be going, actually, let me do it. Okay. So this, if I have it this way, now the side is going up 1 to the right 2. So how do I get that to happen? What has changed here? You could actually make this happen 2 different ways. You could have squashed the y's by a half, or you could have dealt with your x's instead. But it sounds like most of you did the y's. You took your y's and you squashed them down, because normally, right, it would normally be at 1, but now it's at a half. This one would have been at 2, now it's at 1. You see that? And we're upside down. So I think that's why a lot of you were like, okay, so to tackle flipping it over and sort of this shrinking, instead of just multiplying by a -1, let's multiply by a -1/2, and then that takes care of both of those things at the same time. All right, so if I do all of these things, I think I'll get what I want. So I want this to happen to the y, so I put it outside of the absolute value. Going to the right 2 has to go in the absolute value, and what's it look like? You said a -2. I agree. This right 2 would have to have a minus there, and then up 3 would be a +3 on the end. Let us check a point. When I plug in 2, I should get out 3. I do. Plug in another point just for funsies. If you plug in 0, you should get out 2. I do, right? 0 minus 2 is -2. Absolute value is 2 times the -1/2 is -1. -1 plus 3 is 2. Yes. Okay. Did anybody do this? Maybe you had something like, trying to think how this would have to look. Oh, yeah. 2 x minus 2, like that, you said? Sorry. Yeah. This. Okay, hold on. Yep. Because remember, you could have gotten that to make the V go like this to this. You could get that 2 ways. You could either pull them, stretch them horizontally, or you could have squashed them vertically. It's going to have the same effect. So, but then, shouldn't that be a, hold on, let me plug in a point. If you plug in 2, you should get out 3. You do. If I plug in 4, I should get out 2. I think you do. I think this should be a 1/2. That should have been a 1/2. Right? It works for that one because we end up with 0, but if you plug in 4, 4 minus 2 is 2 times a half is 1. Yeah, that should have been a 1/2. Because remember, I want it, because I'm doing the opposite with the x's, right? So if I want the x's, instead of going up 1 over 1, now I want to go up 1 over 2. Instead of timesing by 2, I multiply by a half or divide by 2, right? So I can have that. Alrighty, does that make sense? And these two, believe it or not, are the exact same thing. Why? Because remember, if you have a product, you can split that up. You can split this up into absolute value of a half times absolute value of x minus 2. And the absolute value of a half is just a half, so then it kind of converts back into this thing. But either one of those are the same equation.
Isn't it like whenever you see like an X, don't you divide it? It's not like a multiply? Because like,
You want to divide by whatever this number is.
because normally like when you see like a number on the outside of the parentheses, it's Y, like multiplied by that number. But then when
Yes.
it's X, it's.
So
Y
I want to
multiplied.
do, I want to take whatever this number is and divide x by it. But if I divide by a half, it's the same thing as multiplying by 2.
Yeah.
Yes. Yep. Oh, fun. One more. What's the name of this parent function again? Yes, this is the greatest integer function. So if you recall, you just kind of make these square boxes with 2 funny lines. Kind of like that. Okay, so there's the parent function. Now see if you can figure out what has happened to this thing. Remember what this means, by the way. You want the integer, the greatest integer that is less than or equal to the number you are providing. Evan, you have it?
Yeah, I got 2 times
This thing?
greatest integer
Yeah.
thing, x plus 2 in there.
Oh. X plus 2. Plus 2. Like that?
Yeah,
Okay, what do we think? This should work because look at what I've done. So normally it starts right here with a closed dot, open dot here. I've shifted it to the right 2. So since I'm doing that to the x's, that's a horizontal shift. I want to make sure that it's in there. So a plus 2 there. And then instead of my y's, they normally are like up 1 over 1 basically. And now I'm up 2. So I need to multiply all my y's by 2. Looks perfect. How do we feel? Okay, Ash? All right, so there's one more piece that I just want to practice a few of, but it's on this other sheet. So let me give you this, and then we'll be good to go. Yeah.
on this one, we also do 2 times the thing x plus 4 on the outside of that.
So instead of having a plus 2 here, so you mean
So it'd be,
just an x there,
yeah.
and then a
x,
plus 4 on the outside?
Yeah, would that work as well?
Let's see. Oh. So that's gonna get them separated. Oh, I see what you mean. So you just took everything and then shifted it 1, 2, 3, 4 up that way. Yeah, that should work too. Yeah. All right.
That's the office, Grace.
Yeah. Your phone goes so fast. It's so fast.
Do you need this?
All the bees are distracting. Thanks a lot. Oh, what are you doing? Thank you. First it was on my face.
Yes.
First it was on my face, and it looked like a fire.
Sorry, it's not.
Sorry about that.
It's fine.
For the-
Yeah, what is this?
it looks like this.
Okay, everybody, if you just take a look at the front side here. So basically, this is asking you. All right, I have some random function and this is what I want to do to it. Let me zoom in a bit more. So if I have some random function and these are the transformations I want to do to it, it's saying, okay, if the parent function was x squared, what would that function look like? That's all. So this one, for example, I'm timesing the whole thing by a -3. Then I want to times the x by 2, whatever is inside there with the x. I'm going to square all of that and I have a +1 on the end. Yep. So try it for part B. How would that look? If these are the transformations you're doing on a square root parent function. So hopefully you arrived at that. Did you? Okay, and then C, try that real quick. You can check with mine when you're done. No, they're not bad. But let's try maybe number 4 looks worse. Yep.
Why isn't it 1/2 x?
Right here? What do you mean here?
In, well, it's where- wait, no, I'm wrong. Here,
I could totally be wrong.
I think I'm wrong.
I'm gonna double check. I always start second guessing myself. But I'm pretty sure that that's all you gotta do. Oh gosh, that's not what I want. Oh, who can't? So catchy. Yeah, you're just gonna leave it like that. Because this is describing, these are they've already figured out what the things are that I need to do. When I go to graph it, now this would mean I would divide my x's by 2. Yeah. So let's just jump to one like number 4. That looks way worse. And maybe we'll just try 1 or 2 of those together. So let's see, this thing. Oh, what am I doing here? Yes. So it depends. Who's getting cubed? All of this or just this? So see how it's normally f of x, right? So whatever is in there with the parentheses is happening to the x. Okay, so all of this, if I want to put it into x cubed, all of that's getting cubed. So it'd be 1/2 x minus 5, all of that cubed, and then a +3. So whatever is inside the parentheses right after the f, all of that gets dumped into wherever the x is in your parent function. So if we tried part B, I'm going to take all of this and that's going to go into my denominator, all of it. 1/2 x minus 5. And then I'd have this plus 3 on the side. So try the last one for C. Have it already? Take everything in the parenthesis and dump it inside where the x is. So all of this goes in there. And then the plus 3.
What would be negative 2 over x plus 5?
Yeah, if you simplified it, that's fine. So that's it, okay? So I just wanted you to have some practice seeing, hey, if these are the things, how do you then put it into a parent function? Okay? Well, let's see. I would like you to finish everything. So finish the 2 that we didn't do on the front. And then you've got 9 of them on the back. You come up with the equation and then that's it. Okay? Does anybody have any questions right now before I let you get to it? All right, that is your only homework. I will open that up on Jupyter in just a second. So whenever you're done,